Hey guys, it's Miss Johnson and I'm here to bring you our notes video for Unit 5 Notes 2. Today we're talking about how we can actually graph quadratics. So let's just review from yesterday what we talked about. We found all of these different parts of a parabola or of the quadratic equation. So the first thing I did was identify the a, the b, and the c. The a is always with the x squared term, so this case the a would be -1. B is always with the x term, which is 6. C is always the constant, which is 4. Then I determine, does it open up or down? Well, I know that since my a value is negative, it's going to open down. Then I'd look for the axis of symmetry. And finding the axis of symmetry means I need that opposite of b over 2 times a. So in this case, I have -6 over 2 times -1. That's -6 over -2, or in other words, x is negative or positive 3. -6 divided by -2 is positive 3. So my axis of symmetry is x equals 3. And then that's also the first half of my vertex. Then I plug it in to get the other half. I'd have y is equal to the opposite of 3 squared plus 6 times 3 plus 4. Make sure that you recognize that the negative is not being squared. Only the 3 is being squared. 3 is the only part that's the actual x value. The negative is just out in front. It's not part of the x. Okay, so if I square 3, I get 9, but then I want to make it negative. So y is equal to -9. 6 times 3 is 18 plus 4. -9 plus 18 is 9, or in other words, y is equal to 13. So 3, 13 is my vertex there. And then the y-intercept is always that c value, which is just 4. So that's how we identify all of those parts, and that happens to be a big piece of how we graph quadratics. So at the beginning, the first thing that you need to recognize is, how do we find the vertex? We have to do this first. That's why it's called step 1. Do this first. Okay? Start with the vertex, and this thing is really important. We highlighted this a lot yesterday, but that formula, the opposite of b over 2 times a, you're going to use that a whole lot throughout the entire quadratics unit. After we find that x value, we plug it back in to get the y value, and then we write it as an ordered pair. So I want you to flip in your notes to example 2, and we're just going to practice finding the vertex in problem 2. So in problem 2, I have an a value of -3, I have a b value of 6, and I have a c value of 4. So I'm going to start by finding the vertex. I have x is equal to the opposite of b, -6, over 2 times a, which is -3. That's -6 divided by -6, which is 1. So that's my x value. Now I got to find the y value. Y is going to be the -3 times 1 squared plus 6 times 1 plus 4. Well, 1 squared is just 1, so that's y is equal to -3, because -3 times 1 is just -3, plus 6 plus 4. Those together are 10. 10 minus 3 is 7. So I get here, kind of ran out of room, y is equal to 7, which makes my vertex 1, 7. Okay, so that I know is my vertex. Now let's go back and see what step 2 tells us to do. So flip back to the front of your notes. On the front of your notes, step 2 is to make a table. We want to start with the vertex, and we're going to put this in the middle. Okay, so it's a little deceiving because we're going to put it in the middle of the table. Then we're going to find other values, 2 to the left of that vertex and 2 to the right of that vertex. Okay, so now let's actually do the table for number 2. So flip back to number 2 and let's make that table. In number 2, I'm going to take this vertex and I'm going to drop it in the middle of my table. Okay, so the middle row is this one right here. And I know that that is my vertex. And sometimes it helps if you just put a little label outside of it, just a little V for vertex. Now, I want to go 2 points in either direction. 2 points to the left of 1 is kind of like counting backwards 2 places. So I'm going to count back to 0 and then back to -1. Then 2 points to the right of 1, if I'm at 1 on the coordinate plane and I go 2 to the right, I go to 2 and 3. So that's where I'm getting those values. Okay, so I make a table and then I need to find the y values. So plug all of these in. Well, now 0 is an easy one because if I plug in 0 there and 0 there, I'm left with just 4. This would cancel out, that would cancel out, and I have a 4. Okay. If I plug in -1, it looks like this. These things take up a lot of space, which is why you have multiple sheets for your notes today. So -3 times -1 squared plus 6 times -1 plus 4. That is -3 times 1, and then -6 plus 4. That's y equals -3 minus 6 is -9, and -9 plus 4 is -5. So that what y value is going to be -5. Okay. If I plug in 2, I have y is equal to -3 times 2 squared plus 6 times 2 plus 4. That's y is equal to 2 squared is 4. Always do your powers first. I have people screw this up a lot. You want to take the power before you multiply. That's just our order of operations. So 2 squared is 4. 4 times -3 is -12. And then -12 plus 12, because 6 times 2 is 12, is going to be 0, and 0 plus 4 is 4. So I get a y value of 4 there. And then I need to plug in the 3. So I have y is equal to, that red is kind of bad on green. Y is equal to -3 times 3 squared plus 6 times 3 plus 4. So 3 squared is 9. 9 times -3 is, -27. And then -27 plus 6 times 3 is 18 plus 4. That's -27 plus 22, which is -5. So my y value there is -5. So, okay, now we made the table. Now what? Let's go back to step 3. So flip back to the front of your notes, and let's take a look at step 3. Step 3, the first one is just graph the values from the XY chart. So put those values on the coordinate plane. So then let's go and graph number 2. So if I graph number 2, I'm going to put all of these values on the coordinate plane. -1, -5 is down here. Down 1, 2, 3, 4, 5. 0, +4 is there. 1, +7, so that's 1, 2, 3, 4. Yep, I did that right. 5, 6, 7. 1, 7 is there. Then 2, 4 is going to be right here. Then 3, -5 is going to be down here. And if I connect those, here is my parabola. Now you connect them with a U shape. It's not straight lines. These make a U. So they look like they're going straight eventually, but you want to make sure that that's kind of curved up there on the top. Okay, so we're going to look at those last 2 steps on the front in a bit, but let's just take a look at example 3. So in example 3, oh, and can't forget this. At the very bottom of your front page, it says, don't forget the graph will open up when A is positive. Or in other words, A is positive when A is greater than 0. And the graph will up and down when A is less than 0 or A is negative. Okay, some of you might be asking, well, what happens when A is equal to 0? Well, if A is equal to 0, then there would be no x squared term, which means you just have a linear equation, which is a line. So that's why we don't need to worry about that with parabolas, because that makes a line. Okay, now let's do number 3. So in number 3, I want to start by making the vertex. I always start with the vertex. So I have x equals the opposite of b over 2 times a. That's -2 over 2, which is -1. Then the y value is going to be -1 quantity squared plus 2 times -1 plus 1. Now that negative is with the x value of my vertex, so now it goes inside and it does get squared. And if you type this into your calculator will tell you -1 unless you put parentheses around it. You have to put parentheses around negative values when you're squaring them, because otherwise your calculator only squares the number. So if I put parentheses around this, and we all know this, a negative times a negative is positive. So this is +1 minus 2 plus 1. 1 minus 2 is -1. -1 plus 1 is 0. So again, we put that vertex in the middle. I'm going to have negative 1, comma, 0. And then I need to go 2 points in either direction. So I am going to count backwards to negative 2 and negative 3, and then count up to 0 and 1. Okay, so negative 1, negative 2, negative 3, negative 1, and then to 0 and 1. So notice that my numbers increase as I go down the table. That's why I go backwards, up, and forwards, right, down. So now let's plug in those values. So 0 is really easy. I like to do 0 because 0 means that this goes away, and I'm left with the y-intercept, which is 1. And that makes my life really easy. If I plug in 1, I'd have y is equal to 1 squared plus 2 times 1 plus 1. That was supposed to be a plus sign there. So that is 1 plus 2 plus 1, which is 4. Now plug in negative 1. Y is equal to negative 1 quantity squared plus 2 times negative 1 plus 1. That's y equals 1 positive, again, put it in parentheses. Oh, I already did negative 1. I should be doing negative 2. Sorry, my bad. I'm doing negative 2. So negative 2 squared is positive 4. Again, put it in parentheses in your calculator. You need to see that that's a positive 4. And then plus negative 4 is what that would be, and plus 1, which is going to just give me 1. If I plug in negative 3, I have y is equal to negative 3 quantity squared plus 2 times negative 3 plus 1. Negative 3 squared is positive 9. That's minus 6 plus 1. 9 minus 6 is 3, plus 1 is equal to 4. So that is going to give me 4. Now, some of you may recognize, and maybe you recognize this in number 2 as well. Take a look at the values on either side of the vertex. If you'll notice something about the y values, they are the same. They are the same. That is not a coincidence. As long as you go equal distance from the vertex, which we did, we went 1 unit up and 1 unit down, then your y values will match. They'll be a mirror image. So flip back to your very front page and let's look at those last 2 steps. The last 2 steps say draw the axis of symmetry, which is going to go in the middle, and then mirror the points on either side of the parabola. And that's what happens with that mirror image. As long as you're equal distance from the vertex, you could go a half a unit out or you could go 10 units out. As long as you go the same distance in either direction, you are going to have the same y values. And that's why we call that an axis of symmetry, because it is symmetrical on either side. Okay, so now let's flip to number 4. So in number 4, I have x squared minus 2x minus 8. I need to start by finding the vertex. So I have the opposite of b, which is positive 2 over 2 times a, which is 1. That's 2 over 2, which is 1. So I'm going to draw myself a table. I know you don't have a table written in there, but you can make yourself a table. I'm going to put my vertex down here in the middle. I need to find the y value, so let's plug that in. Y equals 1 squared minus 2 times 1 minus 8. So that is 1 minus 2 minus 8. Holy cow. 1 minus 2 is negative 1, minus 8 is negative 9. So negative 9 is my y value there. Now, count your x values in either direction. So I'm going to go backwards to 0 and negative 1 and forwards to 2 and 3. And remember that as long as you go equal distance, this y value is going to match that y value. So the reason that makes that kind of nice is because really you only have to find 2 of these and you will have these 2. So, and anytime I have 0, I always use 0 because I always know that it's just the y-intercept, which is negative 8. So that means this one's also negative 8. That helps me out a whole lot. Now I need to find either negative 1 or 3. Now it doesn't matter which one you plug in. I like to work with positives, so that's what I'm going to do. I have y is equal to 3 squared minus 2 times 3 minus 8. That is 9 minus 6 minus 8. 9 minus 6 is 3. 3 minus 8 is negative 5. So this is negative 5, which means that's also negative 5. Those two match together. So now let's put them on the coordinate plane. 1, negative 9 is going to be, this is my negative 8. I always lose. Are the numbers on top or on the bottom? They're on the top. So that's 7, that's 8. 9 is a little bit off your coordinate plane, but that's okay. We can put it on there. And the nice thing about this is that now you can draw in your axis of symmetry. Notice that it's a dotted line because it's not actually a line that exists. It's just showing you where the symmetry lies. That's why I made it dotted there. So then 0, negative 8 would be right here, and 2, negative 8 is right there. And that's what the axis of symmetry does for you. You can mirror it across, and it becomes really helpful. And then negative 1, negative 5 is negative 1, 2, 3, 4, 5, goes like this. And I'm 2 units away from the axis of symmetry, so I go 2 units away in the other direction, and that one is negative 5 as well. So the axis of symmetry in that really mirror image piece makes graphing these things a whole lot easier. Let's try number 5. And number 5, I have y is equal to negative 3 times x squared with nothing else, which means I have a plus 0x and a plus 0. So my a value is negative 3, my b value is 0, and my c value is 0. So let's see what that does to our vertex. So for my vertex, I have the opposite of 0 over 2 times negative 3. That's the opposite of 0 over negative 6, and anything 0 divided by anything is 0. If I plug that back in, I'd have negative 3 times 0 squared, which is still 0. So I know that my vertex is actually 0, 0 in this case. So then I need to go to negative 1 and negative 2 and also 1 and 2. I'm just going to find the y values for 1 and 2 and mirror them across that vertex. So my y value for 1 is negative 3 times 1 squared. That's y equals negative 3. And then my y value for 2 is y equals negative 3 times 2 squared. And again, make sure you do your powers and then multiply. 2 squared is 4. 4 times negative 3 is negative 12. Big number there. So negative 3 and negative 12 are these as well. So now let's put that on the coordinate plane. So 0, 0 is my vertex, and the y-axis is my axis of symmetry. So then I go over to 1 and down to negative 3, and I can mirror that across. And I need to go over to 2 and negative 12. This was negative 8, 9, 10, 11, 12. It's kind of far off your coordinate plane, but it's doable. You can see it. You can find it. Just draw it in. And there is your parabola. All right, couple questions left. Let's take a look at the word problem number 6. It says the equation negative x squared plus 4x plus 3 represents the height y of a flying disk x seconds after it is tossed. When will it return to the ground? Ooh, when will it hit the ground? So what we're going to do is we are going to graph this, and we are going to look when it hits the ground, which is y equaling 0, meaning I'm on the x-axis. So that's what ground means, is y equals 0, and I want to know when is that graph going to hit the x-axis. But I have to actually put the graph on the coordinate plane to see that. So that's what I'm going to do. I'm going to start by finding the vertex like I always do. That's negative 4 over 2 times negative 1, negative 4 over negative 2, 2. Plug it back in. The opposite of positive 2 squared. This is where that negative is on the outside because my x value is just 2. I have a negative, but it's on the outside. Plus 4 times 2 plus 3. That's y equals 2 squared is 4 times negative 1 is negative 4. Plus 8 plus 3. That's y equals negative 4 plus 8 is 4. Plus 3 is equal to 7. Woo, there we go. Okay, so let's make our table. Vertex in the middle. I have 2 and 7. So then I need to go backwards to 1 and 0 and forwards 3 and 4. 0, easy. Love it. Always use it if you can. 0 is just going to be positive 3 because it's just the y-intercept there. Let's plug in 1. 1 is going to be the opposite of 1 squared plus 4 times 1 plus 3. That is negative 1 plus 4 plus 3. 4 plus 3 is 7, minus 1 is 6. So that means this is a 6. So mirror those across. That's going to be a 6. That's going to be a 3. And graph them. I have 0, 3. I have 1, 6. I have 2, 7. I have 3, 6. And 4, 3. So there's my there's my parabola. Now let's see if we can answer this question here. Okay, the question is, when will it return to the ground? So I want to know, what is the value that it's hitting 0? Well, it's hitting 0 there and there. And we're talking about time. We're talking about when. So what I know is that time can't be negative. So if time can't be negative, that means this one is out, and I'm really only looking at this one. Now, we can't really determine what exact value that is, but it looks like it's about 5, so that's how I would answer this. About 5 seconds. And I know it's seconds because of that. I always label my answer when there's a question with words, and there you have it. Okay, last question. Number 7, it says a baker has modeled the monthly operating cost for making wedding cakes by the function y equals 0.5x squared minus 12x plus 150, where y is the total cost in dollars and x is the number of cakes prepared. So we want to start by finding the vertex, okay? Find the vertex. So I'm going to do that. X equals positive 12 over 2 times 0.5. That's positive 12 over 1, which is just 12. Y is going to be 0.5 times 12 squared minus 12 times 12 plus 150. Plugging all that into my calculator, 12 squared is 144. Half of that is going to be 72. 72 minus 144, because that's 12 times 12. And then adding the 150, I get a positive 78. You're going to want to check that on your calculator to make sure that you are getting the same values I am. So I know my vertex is 12, 78. Okay, now here's the thing about vertex. You learned yesterday that vertex is the same thing as max and min, a maximum and a minimum. Now in this case, this is going to be a minimum because my graph is opening up. This is an opening up parabola. So I have a minimum down there at the bottom. So minimum cost is my y value, which is $78. And how many cakes should be prepared to yield this? X is the number of cakes. That's 12. So 12 cakes. That's how you take that vertex and turn it into something with meaning. Vertex is the same thing as maximum and minimum. So if you're looking for a minimum, find the vertex. If you're looking for a maximum, find the vertex. Figure out what X and Y mean. We're not actually asked to graph this one, so we can stop there. Thanks for tuning in to your notes today. Don't forget to check your notes sheet off with Ms. Johnson, and I will see you all tomorrow.